Hi everyone, welcome to part 3, A History of Computers. Turing tested. Many of the pioneers of computing were hands-on experiments, but by no means all of them. One of the key figures in the history of the 20th century computer, Alan Turing, 1912 to 1954, was a brilliant Cambridge mathematician whose major contributions were to the theory of how computers processed information. In 1936, at the age of just 23, Turing wrote a groundbreaking mathematical paper called On Computable Numbers, with an application to the Eniac problem, in which he described a theoretical computer known as a Turing machine, a simple information processor that works through a series of instructions, reading data, writing results, then moving on to the next instruction. Turing's ideas were hugely influential in the years that followed, and many people regarded him as the father of modern computing, the 20th century's equivalent of Babbage. Although essentially a theoretician, Turing did get involved with real, practical machinery, unlike many mathematicians of his time. During World War II, he played a pivotal role in the development of code-breaking machinery that itself played a key part in Britain's wartime victory. Later, he played a lesser role in the creation of several large-scale experimental computers, including Ace Automatic Computing Engine, Colossus, and Manchester Ferranti Mark, described below. Today, Alan Turing is best known for conceiving what's become known as the Turing test, a simple way to find out whether a computer can be considered intelligent by seeing whether it can sustain a plausible conversation with a real human being. The first modern computers. The World War II years were a crucial period in the history of computing, when powerful gargantuan computers began to appear. Just before the outbreak of the war in 1938, German engineer Konrad Zuse, 1910 to 1995, constructed his Z1, the world's first programmable binary computer, in his parents' living room. The following year, American physicist John Atomsoft, 1903 to 1995, and his assistant, electrical engineer Clifford Barry, 1918 to 1963, built a more elaborate binary machine that they named the Antonov-Barry computer, ABC. It was a great advance, 1,000 times more accurate than Bush's differential analyzer. These were the first machines that used electrical switches to store numbers. When a switch was off, it stored the number 0. Flipped over to its other on position, it stored the number 1. Hundreds of thousands of switches could thus store a great many binary digits. Although binary is much less efficient in respect than decimal, since it takes up to 8 binary digits to store 3 decimal number. These machines were digital computers, unlike analog machines which stored numbers using the position of wheels and rods. They stored numbers as digits. The first large-scale computer of this kind appeared in 1944 at Harvard University, built by mathematician Howard Aiken, 1900 to 1973. Sponsored by IBM, it was variously known as the Harvard Mark I, or IBM Automatic Sequence Controller Calculator, ASCC, a giant of a machine stretching 15 meters 50-foot length in height. It was like a huge mechanical calculator built into a wall. It must have sounded impressive because it stored and processed numbers using clickety-clack electromagnetic keys, electrically operated magnets that automatically switched lines in telephone exchanges, no fewer than 3,304 of them. Impressive they may have been, but relays suffered from several problems. They were large, they needed quite hefty pulses of power to make them switch, and they were slow. Most of the machines developed around this time were intended for military purposes, like Babbage's never built mechanical engines. They were designed to calculate artillery firing tables and do through the other complex chores that were then the lot of military mathematicians. During World War II, the military co-opted thousands of the best scientific minds, recognizing the science would win the war. Vannevar Bush's Office of Scientific Research and Development employed 10,000 scientists from the United States alone. Things were very different in Germany when Konrad Zuse offered to build his Z2 computer to help the army. They couldn't see the need. They turned him down. On the Allied side, great minds began to make great breakthroughs. In 1943, a team of mathematicians based at Bletchley Park near London, England, including Alan Turing, built a computer called Colossus to help them crack secret German codes. Colossus was the first fully electronic computer. Instead of relays, it used a better form of switch known as vacuum tubes. Okay. Also especially known in Britain as a valve. The vacuum tube, each one as big as a person's thumb and glowing red hot like a tiny electric light bulb, had been invented in 1906 by Lee De Forest, 1873 to 1961, who named it Audion. This breakthrough earned De Forest his nickname as the father of radio because their first major use was in radio receivers, where they amplified weak incoming signals so people could hear them more clearly. In computers such as the ABC and Colossus, vacuum tubes found an alternative use as faster and more compact switches. Just like the code it was trying to crack, Colossus was a top secret, and its existence wasn't confirmed until after the war ended. As far as most people were concerned, vacuum tubes were pioneered by a more visible computer that appeared in 1946, the electronic numerical integrator and calculator ENIAC. The ENIAC's inventor, two scientists from the University of Pennsylvania, John Maliki, 1907-1980, and J. Presper Eckert, 1999 to 1995, were originally inspired by Bush's differential analyzer. Years later, Eckert called that ENIAC was the descendant of Dr. Bush's machine, but the machine they constructed was far more ambitious. It contained nearly 18,000 vacuum tubes, was around 24 meters long and weighed about 30 tons. ENIAC is generally recognized as the world's first fully electronic general-purpose digital computer. Colossus might have qualified for this title too, but it was designed purely for one job, code breaking. Since it couldn't store a program, it couldn't be easily be reprogrammed to do other things. Eniac was just the beginning. Its two inventors formed the Eckert Maliki Computer Corporation in the late 1940s, working with a brilliant Hungarian mathematician, John von Neumann, 1903 to 1957, who was based at Princeton University. They then designed a better machine called EDVAC, Electronic Discrete Variable Automatic Computer. In a key piece of work, von Neumann helped to define how the machine stored and processed its programs, laying the foundations for how all modern computers operate. After EDVAC, Eckhart Maliki developed UNIVAC, Universal Automatic Computer, in 1951. They were helped in this task by a young, largely unknown American mathematician and naval reserve named Grace Murray Hopper, 1906-1992, who had originally been employed by Howard Aiken on the Harvard Mark I. Like Herman Holleritz tubulator over 50 years before, UNIVAC 1 was used for processing data from the US Census. It was then manufactured for other users and became the world's first large-scale commercial computer. Machines like Colossus and Eniac and the Harvard Mark I compete for significance and recognition of the minds of computer historians, which one was truly the first great modern computer, all of them and none, these and several. Other important machines evolved our idea of modern electronic computer during the key period between the late 1930s and the early 1950s. Among those other machines were pioneering computers put together by English academics, notably the Manchester Ferranti Mark I, built at Manchester University by Frederick Williams, 1911 to 1977, and Thomas Kilburn, 1921 to 2001. The EDSAC Electronic Delay Storage Automatic Calculator, built by Maurice Wilkes, 1913 to 2010 at Cambridge University. Okay, the next video I'll talk about the microelectronic revolution. So please like and subscribe. Thank you.